Hey, geometry students. In this lesson, we are going to be taking a look at isosceles and equilateral triangles. Now, remember, isosceles triangles, by definition, have two sides that are the same length. That's it. That's the definition of an isosceles triangle. All other properties of isosceles triangles can be proven from that initial property that two sides are the same length. Equilateral triangles similarly are defined by their side lengths, except equilateral triangles are a specific type of isosceles triangle. Not only do they have two lengths, or two sides of the same length, they have three sides of the same length. And again, that's it. That's where the definition of equilateral triangle ends. Three sides that are the same length. All other properties of equilateral triangles can be proven from that. All right, and in this lesson, we're going to be looking at some properties of isosceles and equilateral triangles that can be proven from the definition of what they are. So we're going to begin with Theorem 51.1, the isosceles triangle theorem, which states that if a triangle is isosceles, then its base angles are congruent. There's some important terminology we need to go over on isosceles triangles. First of all, like right triangles, isosceles triangles have legs. They have two legs and a base. We typically refer to the sides that are congruent as the legs of an isosceles triangle. And then the third side, the non-congruent side, is the base. In an equilateral triangle, you just choose one side to be the base and the other two are the legs. Then we have some angles. The angles that include the base are the base angles. Okay, so one of the sides of the angle is the base of the triangle. And then the angle made up of just the two legs is the vertex angle. And what this theorem is saying is that those two base angles are congruent to each other. So in triangle LMN here, we have angle M congruent to angle N. A corollary, if a triangle is equilateral, then all of its angles are congruent. If it's equilateral, then it's equiangular. And not only that, we're going to find, I'm just going to go down a couple. The converse of that statement is true as well. If a triangle is equiangular, that means it has to have 60-degree angles at each angle, according to the triangle angle theorem. There has to be 180 degrees in a triangle, and the only way to get that with all three angles congruent is to have each angle 60 degrees. So if a triangle is equiangular, then it has to be equilateral as well. And then another theorem, the theorem 51.2, the converse of the original isosceles triangle theorem. If two angles of a triangle are congruent, then the sides opposite those angles are also congruent. Or in other words, if we have two angles of a triangle that are congruent, the triangle is an isosceles triangle by definition. Okay, so we can figure out a triangle as isosceles either with two legs being congruent to each other or two base angles being congruent to each other. And then to wrap things up here, we have two more theorems. If a line bisects the vertex angle of an isosceles triangle, then it is a perpendicular bisector of the base. Here's a picture of that. So we're going to draw a line that bisects this top angle, okay, the vertex angle of our triangle. If we draw that line, it's going to not only intersect the base as a bisector, but it's going to be perpendicular. So that will be a perpendicular bisector. Then we have theorem 51.4. If a line is the perpendicular bisector of the base of an isosceles triangle, then it bisects the vertex angle. Do you see that these two are converse of one another? So if a line is a perpendicular bisector, the base of an isosceles triangle, that it has to bisect the vertex angle. Just like if a line bisects the vertex angle of an isosceles triangle, it's going to be a perpendicular bisector of the base. Okay, those are some relationships we're going to practice with as we work the practice problems for this lesson.